This is lesson 2.3, solving two-step equations. We are going to first recall what PEMDAS is. For PEMDAS, we use it for order of operations when we have a problem that looks like this. So if we have 2 plus 3 squared in parentheses plus, 8. We'll just do that. When we use PEMDAS, we got to look and see like what we do first. For example, it's always parentheses first. You can zoom in here a little bit. Parentheses first, meaning we would have to deal with the inside of the parentheses, which would only be this stuff. Then we'd have to deal with exponents. So exponents inside the parentheses would be that one. That's what we would have to do next. Then we don't have any multiplication or division on this one, but addition and subtraction we would go from left to right. So that is how we do PEMDAS forward. Today we're going to do it backwards though, because we have to do it backwards when we are solving for variables. When we are, for example, solving for u in this problem, we're going to do PEMDAS backwards. And I'm only going to show you the intricacies on the first few. For example, this one has addition and multiplication, so So if we have addition and multiplication, we have to find a way to get rid of the addition first. So we have to get rid of this 3 plus and leave this multiplication that's happening. There's a 3 times u there. You just don't see the multiplication symbol. We just assume that it's there. We are going to wait for that one until we get this plus 3 away from it. So to do that, we have to subtract 3. If I subtract 3 over there and subtract 3 over there, this would be 12 equals, this is gone, 3u. Now we can get rid of this multiplication by doing the opposite, which is division. Divide by 3, divide by 3. 12 divided by 3 is 4. 4 equals u is my final answer. Oh, no, it's not. It's actually not my final answer. Sorry, I almost forgot. We have to switch that around to be u equals 4, doing the symmetric property. We can never have our number equals a variable. We have to have our final answer as a variable equals a number. So symmetric property allows us to do that. Coming over here, 268 minus y equals 221. Now this one is actually probably the trickiest one on here, because you might see only one operation, but there's actually more than one that we're going to have to take care of. I'll show you this in just a second. It's a hidden operation that you actually don't see yet. I'm going to subtract this 268 first, because again, we're just trying to get it away from y. Minus 268 on both sides. These cancel out. We're going to be left with our negative y equals negative 47. Now, a lot of people get that wrong because they think they don't have to put this negative next to the y. They just put y equals negative 47 and they're done. They don't realize that this negative y has to come down. We didn't get rid of the negative by subtracting 268. We just got rid of the 268. That negative or subtraction symbol is still there. And since negatives are the same as subtraction, that's still in front of that y. Now, the hidden operation is actually in between that negative and the y. I think you would agree that negative y is the same thing as negative 1y, right? So, right now we have a number that's being multiplied by that y. It's a negative 1 times y. So we're going to have to get rid of that negative 1 by dividing it, which is the opposite. Now the negative 1's cancel. Y is actually by itself. And negative 47 divided by negative 1 is positive 47. And now we are done with that. On to the next one. This is another tricky one because we have a giant division symbol right there. And I tell my students whenever they see a giant division symbol, there are hidden parentheses on the top and the bottom. Now I'm not going to write the hidden parentheses on the bottom because there's only one number on the bottom, so I don't need to put parentheses around just one number like this. So I'm just going to leave it there. Since we're going backwards order of operations, even though addition comes first going backwards, we can't do that yet because it's locked inside those parentheses. Until we get rid of that 9, then the parentheses will unlock. So I'm going to multiply both sides by 9 because it's being divided by 9, so we got to do the opposite. 27 equals x plus 38, because these 9's cancel out, and the parentheses are unlocked, so I don't have to write the parentheses because we got rid of that 9. Now we subtract 38 from both sides, and we get negative 11 equals x. Now we have to flip those around using the symmetric property. Again, we have to have that variable come in first. Okay, next. This is another tricky one, just because now we have another thing that we have to look out for. I'm going to do this pretty quickly, but I have a lot of students think that all three of these are different. I'll write them down here. So 4 over 2, 4 over 2, and 4 over 2. Now, is there a difference between this, and then a negative being right out front? So negative 4 over 2 versus 4 over negative 2, and then negative 4 halves. I have a lot of students think that those are different. They're actually not, though. They are all equal because, well, if you take negative 4 divided by 2, that's going to be negative 2. If I take 4 divided by negative 2, that's still negative 2. And if I took 4 divided by 2 and then added a negative, well, that's negative 2. Those are all the same. So, what I'm getting at here, the whole point that I'm trying to make, is that I can actually take this negative and erase it and move it to right there. And it's not really changing anything. I just like to do that because now I can put my parentheses around it and lock it in those parentheses and just wait on it till later. Again, we have hidden parentheses up top, so I'm going to get rid of this 5. Cancel those out. I'll be left with that negative 3u, and it becomes unlocked because we got rid of that 5 off the bottom. Negative 9 times 5 is negative 45. Divide by negative 3. Divide by negative 3. U equals positive 15. Again, I divided by 3 because they were being multiplied right there. Negative 3 times u, so I did the opposite. Next one, I've got 3w plus 5w. Right off the bat, I know I have to combine like terms. 8w equals, 48. Divide by 8, divide by 8. W equals 6. Next one, I've got multiplication and addition, so let's get rid of the addition first because that's backwards PEMDAS. 9c, these are gone, equals positive 9. I'm dividing by 9 because it's being multiplied there. So these are going to cancel. C equals 9 divided by 9 is 1. Next one, we got to add 5 first. Add 5 to both sides. 6y, these cancel, equals 12. Divide now because that's the opposite, and I got to divide by 6. And divide by 6. Y equals 2 because those canceled out. And we're moving on. Next one, adding 4 to both sides. This is 12 equals 3a. Divide now by 3 because they're being multiplied. We're just doing the opposite. 12 divided by 3 is 4 equals a. Got to switch those around though. A equals 4 using the symmetric property. Next one. We have division and addition. Again, we got to get rid of the addition first. So m over 5 is left over. These are canceled out. Equals 2. Now multiply to get rid of the 5 on both sides. Cancel, cancel. M equals 10. Okay, on this one we have multiplication in there that you don't see, but it's there, and addition. Let's get rid of that addition symbol by subtracting. So these are gone. 2r equals 34. Divide by 2, divide by 2. R equals 17. And we are on to proofs. Okay, so for these, we need to list our steps on the left, basically how we're solving, and then we need to put our reasons on the right. First of all, we're always going to put the first reason as given. That's the problem that was given to us. We're going to write given. Next, on this one, this is the same one as basically this one up here. So I'll let you re-watch that if you're confused on what I'm doing here. But I have to basically get rid of that 9 first. So 12 minus 9 equals 9 minus w minus 9. Now if you look at what I'm doing here, I basically just subtracted 9 from both sides. What I've highlighted is the only thing that was added to the original problem. If you just look at what I wrote down, and if you were to imagine those negative 9s that I highlighted to be gone, it'd be the same thing as the top. I just subtracted 9 from both sides, but I have to put them all on one line. I cannot do this, minus 9, minus 9, like that, like we did on the top. Since we're doing a proof, we have to write them all on one line. This is like your final draft of an English paper. You know, you can have a rough draft and a final draft. We're doing a final draft here. So no scratch work, no crossing out numbers or anything like that. So what did we do there? We did the subtraction. And I'm going to run out of room, but it's called property of equality. And I'm just going to abbreviate because I don't have enough room, but I'd like you to write it out. Subtraction, property of equality. Scrolling down for the next one, we are going to simplify. We always simplify after a property of equality. So 12 minus 9 is 3 equals, and these two 9s, there's a positive 9 here and a negative 9 there. Those are going to cancel out, but I'm not going to cross them out on my paper. I'm just going to leave my negative w. That's the only thing that's left over because the 9 and the negative 9 are gone. Now, we have to remember that there's basically a negative 1 in front of that w. And if you don't remember that, I need you to go up and watch this one again. It was the second one we did, and I said it's the most difficult one on here. But there's a negative 1 in front of that w. So I'm going to divide by negative 1. Oh, I didn't mean to do that 3 there. Let me try that again. Negative w over negative 1 is what I meant to do. Okay, so now we're dividing on both sides, so that is division, property of equality. 3 divided by negative 1 is negative 3 equals negative w divided by negative 1 is just w, and then we have to flip those around as well. So we simplified there, and then at the end we use the symmetric property. Okay? Next one. Okay, so we have 8 over 4, or I'm sorry, x over 4 minus 8 equals 2. So to do this one, we are going to first add 8 to both sides. X over 4 minus 8 plus 8 equals 2 plus 8. Okay, and then after that, we are going to simplify. We'll have x over 4 equals 10. And then we are going to have to multiply both sides by 4 since it's being divided. 4 times x over 4 equals 10 times 4. And then finally, those 4's cancel out, and we're just left with x equals 40. Now, real quickly on these steps, we have given, always as the first one. We added 8 to both sides, so it's addition, property of equality. Then we simplified Then we did multiplication. Property of equality. And then we simplified. I guess simplify. I'll put. All right. So that's it for this lesson.